Alright guys, this is it. And this is the last set of notes. You're going to have to listen to me forever. Alright, applications of producer surplus and consumer surplus, which we'll do both by hand and on the calculator. You should know how to do both, alright, by hand and on the calculator. If I ask you to do it by hand, you can, or if I tell you can do it by the calculator, you can do it on the calculator. Alright, we always do them together. We'll set up the producers and consumer surpluses together. Alright, so the first example. Suppose that we have a furniture company that's willing to supply X office desk at a price. Alright, by that supply, right, supply goes with the manufacturer. So P represents the price in dollars. X is the number of office desks that they plan to bring to the market. Consumers are willing to buy X office desks, right, demand X office desks, if they have a price set at that price-demand equation, right? That's our price-demand. Alright, so the first one is sketch the graphs of the supply and demand functions, label your intercepts, and kind of label everything, alright? Label your axes and all of your parts that are important, and I'll show you exactly what I want to see. To get a fairly good looking graph, though, I am going to go to the calculator, because we're actually going to use both the calculator and by hand to solve these. Alright, so I'm actually going to graph both of them in the calculator. Again, I only need a standard window, but I will have to adjust my window based on my application. Straighter line than that. Alright, so only in the first quadrant, right? Our X represents office desks. Those can only be positive. And our Y represents the price in dollars, right? That's the Y-axis. Alright, so I already know where they're going to start. When I plug 0 into my supply function, right, we start at 0, it comes out 0, right? That would be my supply at 0, that's 0. Alright, my demand, when I plug 0 in, it's at 800. So I'm just going to go up here. Demand at 0 is 800. Supply at 0 is 0, the origin. Alright, so then I'm going to go to my graphing calculator and plug it in so I get a fairly decent looking graph, and I'm going to use it to find my equilibrium point anyway, and I'll use it to find one of my functions, either surplus or producer, I can't remember which one. Alright, so I'm going to go and graph these on my calculator. So I'm going to go plug these in, and I will adjust my window so I make sure I see them. Alright, so going to my graphing calculator in my y equal. Looks like I already have them plugged in, double checking, make sure I've typed them in right. So I've got my supply, which was x squared plus 15x, my demand, which was 800 minus 5x. Alright, but I am going to adjust my window. Alright, x values represent number of office desks. Can't have negative office desks, so that needs to be 0. And this is sort of guessing. I'm going to ballpark it at 30 and see if that gives me a good enough window. I may still have to change. The X one I kind of have to guess at. Alright, my Y again stands for price, so 0 is where I'll start. And then I know my demand was at 800, right? That was my big value. So I know I need to go above 800. And so I'll probably go to 1,000. Just making sure I can see everything on my graph. Alright, so I'll go graph it. So there's my supply, there's my demand. I can see it plenty good, so my demand and supply are fairly high. I'm going to go ahead and find the equilibrium point. Alright, so second trace, intersect, so 5. First curve, second curve, and guess, and then I'll go draw it on my notes. Alright, looks pretty good. Enter. Pretty good, so enter again, and enter again. Alright, so it intersects, and I need both of them, at 20 desks and the price of $700, right? The X value is price. Alright, so I'm going to try copy that on my notes. Alright, so the supply curve was a parabola moving up. Alright, there's my supply, label it. And then they meet somewhere around here. Alright, my second point on my demand, which is a line. Alright, and there's my demand function. I know what this point is. My X value was 20. My Y value was 700. And so there's my equilibrium. 20. And my equilibrium price, 700. Alright, so if they set the price to 700 per desk, right, they should sell 20 per week, per month, per day, whatever the time period is. Right? And that will be their market equilibrium point. Right, so there's the answer to A. Find the equilibrium price and quantity labeled I already labeled it on my graph. Alright, so my equilibrium price with units is $700 per desk. And my equilibrium quantity, well, if they set that price, they're going to sell 20 office desks. More precise. Alright, over whatever the time period is. Days, weeks, months, whatever. Alright, but there's my equilibrium point. 700 for the price in dollars, and quantity is 20 desks. Make sure you give units, right? Units are always important. 700 has meaning, 20 has meaning. Alright, shade the region that represents the consumer surplus. Find it using the definite integral. Show it, solve by hand, and then we can check using the calculator. Alright, means producer surplus. I'm going to probably find using the calculator. Alright, so remember, consumers go with demand, right? The consumers are buying using the demand function. Manufacturers is a supply function, and so I look at my demand function, which is this one, and the consumer's surplus lands above the revenue generated. So there's my area I want to find. So this is the area I'm looking for. Alright, that's my consumer surplus. Which means the big area is under my demand curve, right? The big area goes from 0 to 20. Under the demand curve, I subtract away the rectangle, the revenue. Alright? And so when we go to find it, consumer surplus, integrating from 0 to 20, right? I want to integrate from 0 to 20, right? The total area here. Under the demand function, first, that finds the big area. So the demand function was the 800 minus the 5x. Alright, but that's not what I want. That just gives me all of the area under the demand curve. All of the amount spent, willing to be spent by the consumers. Alright, what they did spend was the revenue, right? Revenue was, again, that's price times quantity. Well, our price and quantity is our equilibrium price and quantity, and so they spent 700 on 20 desks. 700 is the price, 20 is the quantity, and that's what we're going to solve. Alright, so I'm going to solve it by hand first, and then we'll check it on the calculator. I'm actually going to add a part to this question, so I'm going to give myself some space. So I add my... Alright, Alright, by hand first, though. Solve by hand. So that means I'm going to find my integral, so consumer surplus. Alright, first thing we do is find the general antiderivative, which is 800x minus 500x squared. Divide by 2 from 0 to 20 minus 14,000, right? If I take 700 times 20, it's 14,000. So I have to solve this. This one's not too bad, because I only really have to plug the 20 in, not 2, that should be 20. Because when I plug 0 in, it just subtracts away and is nothing. And so all I really have to plug in here is my 20. Alright, so when I take 20 and I plug it into my general antiderivative, it comes out 15,000. 15,000 minus 0. And so it's 15,000 minus 14,000. So the consumer surplus is $1,000. Right? That's the extra money that the consumers felt like they saved. Alright, they would have been willing to spend that, but they didn't have to. Alright, so that's the consumer surplus. I will add to this, so this isn't in the notes. I meant to add the part D. We will be finding the producer surplus. So on part, I'm going to add part D, find the producer surplus, and I'm going to do this on the calculator. Alright, so I'm going to go to my graphing calculator. And first of all, I'm going to check this answer, right? It says check on the calculator. So I'm going to check this right. And what I'm really checking is that this integration was 15,000, right? That's really what I'm going to go check. I don't really need to check the revenue. That's just finding it. Alright, so what I'm checking is this. Alright, so I'm going to go to my calculator. And the biggest thing about going to the calculator is when you go do this, you're going to integrate. So we're hitting second trace. 7. Make sure your cursor's on the right function, and mine's not. My cursor is on the supply function. I'm not dealing with the supply right now. That'll be my next question. I'm dealing with revenue, so I actually have to hit my up arrow. Alright, so I have to hit this up arrow, and now I'm on my demand curve, right? So I hit the up arrow and I'm onto my demand curve. Now I'm on the curve that I want to be on and find my area of. And so I type in 0 as my lower limit, and then I type in 20 as my upper limit. And there we go, is my area, and so it checks. 15,000 is the area under the demand curve, which if you look at this is not the area I want. That's that total area. I really wanted just a small piece of that. I had to subtract that revenue in order to get the small piece that I'm looking for. But this checks that I did do my integration right by hand. Alright, so I'm going to go back to my picture and it checks. Alright, so that is my consumer surplus. Alright, now my producer surplus, which again, this is added to the question. And so remember, this is the producer surplus. So if I, again, draw this in, this yellow area, which again, I didn't ask you to do this. We're just kind of adding to the problem here just so that we can. Alright, just to give you another example. Alright, so that's the area I want. And so the first thing I find is the rectangular area, right? That's the big area, rectangular area. And so my producer surplus, if I'm setting it up, well, it's the revenue generated first, which was our price, 700, times our quantity, 20. But that's not what that would be the total revenue. Right? We want to subtract away what they would have been willing to settle for. Well, I want to subtract away the area under the supply curve. So integrating from 0 to 20 under my supply curve, well, the supply curve was x squared plus 1500x. Right? That would be this area down here. I want to subtract away the area under this supply curve. And then what's left over is the area I want, which is my producer's surplus. Alright, and I'm going to do this all on the calculator. Alright, so producer's surplus, well, the revenue I have, that's the 14,000, minus the area under the supply curve. And so now I'm going to go to my graphing calculator. I'm going to regraph. And so usually it's change your window maybe a little bit to regraph. Alright, and then it'll get rid of the shaded area. Alright, so now I've got a clean graph. Alright, now I want to find the area under the supply curve. So again, I'm going to go to second trace, 7, and I'm going to make sure, and I'm good. Alright, my cursor is showing up on my supplied function, so I don't have to move it. It's good. Integrate from 0. Enter, 20, enter, and it'll shade that area in. Remember, that's not the area I want. I want the area above that, right? But I'm going to use that to find the area I want. So the area I want to throw away, get rid of, is 5,666 repeating. So I'm going to round to the penny when I go back to my grid. So 5, 6, 7. All right, that's the area under the curve. And then when we subtract, it comes down to $8,333.33 producer surplus, which again, like I said, it usually is more. Right? Consumer surplus was only 1,000. Producer surplus is a little bit more than 8,000. All right, now we're just going to practice a couple more examples of that. All right, next example. We've got Scott, who's willing to supply X of his storage cabinets at a price of, given that price equation, supply equation, he found that the consumers, the buyers, are willing to demand X of his cabinets at a price of this price-demand equation. All right, sketch the graph. Again, this is what we're looking for. This is typically how I word it on the test and worksheets. Label your graphs, your intercepts, your axes, and find and label your equilibrium. All right, well, I'll start off with the grid. All right, I'm going to give myself a little more room to draw. All right, so always the first quadrant. All right, the X value is the cabinets. All right, this is the price in dollars. Our intercepts are 0 for supply, right? If I plug 0 in, I get 0 out, so supply at 0 is 0. And then the demand at 0 was 150. All right, so again, label your intercepts. That's where we're starting, right? When I plug 0 into the demand, it's 150. All right, now I'm going to go graph it so I get a fairly decent looking picture. So I'm going to go in here and then clear out what I have, type in my new equation. So my new supply is x squared plus 20x. And then my new demand is 150, 150 minus x squared. Alright, I am going to change my window. I'm probably going to leave my x, although that's probably a little big. I might change that. Just based on the fact that demand starts at 150, it'll probably be less than what we did. I might change that to 15 and see if I still need to go there. And I don't need to go up to 1,000. It's only 150, so I'm just going to do 200. Alright, and see if it gives me a decent set of supply. Alright, that looks like a good picture. I find my equilibrium point. Alright, so second trace, intersect, first curve, second curve, and gas. So usually I just get it down as close as I can. Good enough. And then hit my button 3 times. Alright, so he's going to sell 5 cabinets if he sets his price to $125. Alright, so making sure they're both curved, right? Supply curves up, demand curves down. So there's my supply labeled, my demand labeled. Poorly labeled, but they're labeled. And then my equilibrium point. So that was at 125. Alright, so my quantity is 5 cabinets at equilibrium, and my price at equilibrium is $125. Alright, so there's my supply and demand, my revenue marked off, consumer and producer surplus. Alright, so I found the equilibrium price and quantity. My equilibrium quantity is 5 cabinets. My equilibrium price is that they sell for $125 per cabinet. Alright, so units, cabinets, dollars per cabinet. Alright, label the region that represents the producer, surplus, and consumer. So this is just label it. Alright, so consumers is here. That's my consumers. It's above the dotted line. Producers is below. Alright, those are the 2 areas. We're going to find both of them. One of them by hand and one of them with the calculator. Alright, so I've labeled the regions that represent producer surplus, consumer surplus, write the expression with the definite integral that represents the producer surplus, and find it by hand. So this time we're going to find the producer surplus by hand. Well, remember, the producer surplus is the revenue is my big area, right, the box. Right, if this is the producer surplus, the big area is the box, so price of 125 times a quantity of 5. Alright, so 125, the revenue generated, minus the area under the supply curve from 0 to 5, right? The supply curve was x squared plus 20x. Alright, and now we solve it by hand. So we just take that, multiply it out, that comes out to 625 minus, find the general antiderivative, which is x cubed divided by 3 plus 20x squared divided by 2. Still have to plug in my 5, because when I plug 0 in, it zeroes out. So 625 minus, when I plug 5 in, it comes out to 291.67. We subtract away 0. And so we really take 625 minus the 291.67, and that will be my producer surplus, which is a dollar amount, and it comes out to 333.33. Right. All right, so $333.33 and change is my producer surplus. Alright, by hand. You could check it on the calculator if you want to. I do believe that is the right answer, though. Alright, the second part of this is write the expression with the definite integral that represents the consumer plus, and this one we will solve on the calculator. Alright, so consumer surplus, though, first write it out. Alright, so remember, this is the consumers. It's underneath my demand curve, right? This is my demand curve up here. And so the first thing I want to find is the total area under my demand curve. And so the total area of my demand curve is integrating from 0 to 5, right? 5 is where my equilibrium value is. My demand is 150 minus x squared. Right, but that would be the total area. I don't want the total area. I have to subtract away my revenue. And remember, revenue was 125 times 5, right? The price and the quantity, right? Price was 125, quantity was 5 cabinets. And then I solve this, and I'm going to solve this on the calculator. So I'm going to find my area under my demand curve on my calculator. 5 times 125 is that 625 I found before. Alright, I'm going to go find this, though, graphically. So I'm going to go to my graph here. I'm going to hit second trace integrate, so 7. Making sure, so moving my arrow, making sure I'm on the right function, and I'm not. I'm down here on my supply function, so I have to hit the up arrow to move me up to my demand curve. Otherwise, it won't find the right area. Alright, so I'm on my demand curve, integrating from 0 to 5, and it'll shade all of that area. So all of that area under my demand curve is 708.33. And then I subtract away the revenue. So I take my 708.33, which is my total area, subtract away that revenue, 625, and it comes out to $83.33 is the consumer surplus. All right. Okay, the last one. So this is it. The last applications we'll be doing together. All right, so suppose we've got the following consumer surplus, or the consumer supply and demand functions. All right, suppose we're willing to supply X tablets at a price of that supply equation, given in dollars, and found that the consumers are willing to buy, demand, X tablets when the price is set at that demand equation in dollars. All right, so sketch the graphs. And again, I didn't give myself enough room. All right, and we'll be doing this entire problem with the calculator. All right, so we're going to sketch first. So sketch the demand, label everything. So label your graphs, your intercepts, your axes, all with correct units. And so I'm going to go here and clear it out and set it up because we'll be solving this graphically. All right, so first my supply equation. So 2x squared minus 30x plus 300. And then my demand, so clear that one out, which was negative 10x plus 10,050. Not 10,050, 1,050. All right, I will have to change my window. All right, these numbers are a little bigger, so I might go up to 30 again just to be on the safe side. And my demand's y-intercept was 1,050, so I don't know I need to go past 1,050. So I'll probably go maybe 1,200 should be good enough. Hit the graph. Supply, demand. Alright, I can see everything pretty good. I want to find that equilibrium point, and then I'm going to go sketch it all out. Alright, so second trace intersect. First curve, second curve, and gas. Alright. Too far. Hit my button too many times. Alright. First curve, second curve, guess. Alright, so equilibrium quantity 25. So our tablets need to be set at a price 800. And we will sell 25 of them in our market. Alright, so going back to my graph and graph that all out and label everything carefully. Alright, so sketching my graph in the first quadrant. This represents tablets. This is price in dollars. Alright, my supply actually starts up at, when I plug 0 in, I get 300 out, so that one doesn't start at 0, it starts up here. My supply at 0 is 300, and then it did kind of, if you go back and look at the picture on the calculator, it kind of went down and then up. Alright, so there's my supply labeled. Then my demand was up here at, my demand at 0 was 1,050. And again, it hit somewhere around here, and it was a straight line. Alright, so there's my demand. Alright, the moment that they hit was at 25x, 800 was my price. Alright, so my equilibrium quantity was 25. My equilibrium price was 800. Alright, so there's the picture with everything important labeled. And I want to see those labels when you go give me your answers on the worksheet and the test. Alright, so there's all the important labeled. Everything has units, everything is labeled, everything is clear. Alright, I already did A, equilibrium price and quantity. We already labeled it. Alright, so my equilibrium price is $800 per tablet. Quantity is 25 tablets. Alright, with units, right? Everything always with units with applications. Alright, label and shade the region with the producer surplus. So I'm going to go up here, label producers is this one, the big area. Shade it in, I'm going to shade it in with a different color. Alright, so this underneath the dotted line and above the supply curve is the producer surplus. Alright, so that's what we're looking for. And I'm going to solve it all on the calculator. Alright, now I am going to have to set up, and I say this, whenever you find this, alright, always give me the integral that I'm looking for. So producer surplus, what you're solving. First thing is your revenue, the box area. So the revenue was, our price was 800, our quantity was 25, right? That's the amount of money the producers get from revenue. But we're subtracting away the area under the supply curve. So 0 to 25, right? We're integrating 0 to 25, and we want to get rid of this area here under the supply curve. So I'm going to subtract the integration of the supply curve from 0 to 25. Alright, so my supply function was the 2x squared minus 30x plus 300, and I didn't say I have to do it by hand, so I'm going to solve it on the calculator. Alright, which means I'm going to solve this part on the calculator. This I can just multiply out, that's 20,000. Alright, but I'm going to go solve this. I'm going to go to my calculator where I've got my picture, and I want to find the area under the supply curve. So make sure we're solving under the supply curve. So second trace integration 7, making sure I'm on the right function, and I am. Alright, that's my supply function. So I'm integrating from 0, enter, to 25, enter, and it should shade under the supply. Remember, that's the area I don't want. I throw that away. I want to subtract that from my revenue. Alright, so I'm going to take that 8,541 and 67 cents and subtract it away from my 20,000. So 8,541.67 is the area under my supply curve. And so the difference between those two amounts and the revenue they generated minus the amount they would have been willing to settle for is the surplus, which is $11,458.33. Alright, that's the area. That would be this area, right? That would be the 11,458.33, that area there. Now the consumer surplus. Alright, write the expression with the definite integral that represents the amount of, oh, I have producers twice, this should be consumers. Consumer surplus, so I already did producers. Alright, didn't ask you to shade it in, but I'm at the very least going to label it, right? This is the consumer surplus that I'm looking for up here, right? That's the area I want to find. And so remember, the consumer surplus is the big area, is the area under the demand function, and then I subtract away the revenue. Alright, so the definite integral for the consumer surplus is integrating under the demand curve to our equilibrium point, so 0 to 25, because 25 is my equilibrium x value. My demand was the negative 10x plus 1050. Subtract away the revenue, which was the 800, or not 800. Oh no, it was 800 times 25. Alright, and I'm going to do it all on the calculator. Alright, find it on the calculator. And so again, this is the part that I'm going to find Oh, I see what I did. Alright, I actually skipped a step. Alright, but hopefully you can follow along. Alright, we're finding the consumer surplus. So we're doing actually this up here. Find it using the calculator. Alright, so the consumer surplus on the calculator minus the revenue, which we already found earlier, was 20,000. Alright, so now I'm going to go back to the calculator and find this area. Alright, if you want to regraph it to get rid of that again, you just basically go and change a little bit on your window. Alright, and it will regraph it, and so you got rid of the other area. Alright, which sometimes that's helpful to do just so that you can see what's going on. Alright, now I want the area under the demand curve, so second trace, 7. Make sure I move my arrow up so that my cursor is on my right function. I want to be on the demand function. Alright, so my cursor is on the demand equation. Integrate from 0 to 25. That equilibrium should shade up all the way to the equilibrium. Alright, so there's the total area. 23,125, which is what I want. So that's 23,125. Subtract away the revenue, the amount they spent. So this is how much they would have spent. This is how much they did spend. And so the difference is $3,125. So there's the consumer surplus. Alright, the extra amount they spent. And now we're done. And you're going to have to find a consumer surplus and producer surplus on your test. I will ask you to solve it this way. And what I'll probably do is I'll probably ask you to do one by hand and one on the calculator. And I will ask you to draw the picture and label all the important parts. Alright, so make sure you know how to draw the picture and label the important parts. And it's up to you. You can either memorize the consumer surplus and the producer surplus equations, or you can use the pictures to help you out. Like, it's kind of what I was doing as I was walking through the problems. Alright, but you will have to do one of these on your test, where I'll ask you to find one of them probably by hand and one of them on the calculator. Alright, we will stop there and we are done. The semesters, or at least the last of the notes, are over. The rest is just studying, practicing, and preparing. Alright, we are done.